Hello, it's What the Doodle here, and this is just a quick session update on the previous video, which was related to building the krunVM. And obviously, building this is quite involved, and obviously it failed before. And if we have a look at where the in terms of the complexity of that build, so this is krunVM is the actual project itself, but that depends on building libkrun, and libkrun itself, which this is a separate project. It depends on another project, which is libkrunfw, and this is the Linux kernel, but that's compiled into a library, a dynamically linked library. And this was eventually successful, and I didn't think it would compile, but it did. And once this compiled, I tried compiling this. This is in the previous session. This is where essentially I got stuck. And at the time I assumed it was because the paths were incorrect, and that was the correct assumption. And once I corrected that, that was able to compile, and finally we were able to compile krunVM. Now I can show you essentially if we go. So the issue is when it built one of the issues, if I go back to here on GitHub, one of the issues was, and this is actually sort of my own, if we go to libkrun, what I had done, and initially if we go into krun, because in the dependent, it will say in the dependency, which is libkrunfw. So this is right at the bottom of the dependency tree. And what I had done, one of my mistake was to actually build the SEV variant, and that wasn't actually required. That was not a requirement. That's only if you wanted to have that specific things. And really, you could just do make and sudo make install. I probably should have tried with that. So I cleaned everything out in terms of everything that was built. So I just did make clean, and I went in manually and deleted all of the artifacts that was generated, because obviously when you install it, installs it into certain paths and everything. So anyway, I cleaned all of that up, and after cleaning that up and just not doing the SE variant, there seems to be issues around that. This generalized version of the generic variant, I was a lot more successful with this, and was able to build that. So if we go back now, once it builds it, it actually builds it here in so USR local lib64. And if we go here, you can see all of the so the two different dynamic libraries are both built. So we can see the libkrunfw, which is here, and also the libkrun as well. So these are separate. These are compiled separately, and they depend on each other. And so they have been both built. Now the issue is when you build. So if you go back to here, when you try and build libkrun, this unfortunately is the linker assumes. So if you go back, the linker assumes that it's actually in the lib64. It's in the system wide, so it believes it's actually here. This was the actual issue. So if you do something like, and the reason and the way I've discovered that was, I looked at ldconfig. When you run ldconfig, this kind of tells you the config, the sort of the library paths that it's using, and it's looking up, and we can see that the actual path, is set to user lib64, which is a system-wide one, not user or USR local lib64. So it wasn't using the local; it was using the system-wide one. Now, you can set. So you can do, if we clear this, for example, you can do sudo ldconfig, and you can set the actual library path. So you can say local lib64, and let me just try. I don't think you need to, maybe. Okay, permission denied. Anyway, so I didn't get these issues, probably because I may be inside a sort of builder unshare session, because that was another issue that I ran into. But anyway, that didn't actually resolve the issue, and the make file, whatever, it was still looking in the system-wide location. So grudgingly, I had to do a bit of a dirty hack and essentially just manually by hand move that over, and that's what I did. So if I then if we grep, for example, libkrun, I manually moved essentially from the local, from the USR local lib64. I manually moved it over here, and once I did that, everything else finally built. It's a little bit. This is a bit. It's a hack. I don't like it. I shouldn't have to do that. But just following the actual instructions as is, it didn't work out of the box. And anyway, however, that does mean if I go now, and I can prove, for example, if I go into the desktop, and we go into krunVM, and we have a look at that, we can now go into the target. Oh, I can I could potentially just build it again. So target build release. And it's finished, so that because I've already built it, so I don't need to rebuild it again. But if we go into target and we go into release, we can have a look, and we can see it right there. So this is the krunVM, and we can prove that works because we can do krunVM and -- help, for example. And there you go. So we have all the commands. So this is, this can create micro VMs from OCI images. That was the original thing. And so, for example, and I have already created. Let's just build one. So let's do krun VM create, and we're going to create a new one. We're going to just use the Alpine image because I already have that downloaded, and we're going to give it a name, something like Alpine-2. And if we run that, and now this micro VM has been created, and we can now see those virtual machines. We can do list, and I've already created. So here you can see Alpine 2 is the one I just created, and Ubuntu test is there as well as an original Alpine test that I've done before. And in theory, you should be able to just run it, but it doesn't work because I'll show you in a second. It just does a core dump with your it does a segfault. krunVM start, and we want to start, for example, the Alpine-2, and we want to start perhaps a shell, for example, and it blows up. we get a segfault, and obviously you can run a full backtrace on that. And if we did something like that, so if we did rust backtrace equal to full, so yeah, it's not inside of it's outside. So actually the if we go back and so it's actually somewhere in the libkrun or the libkrunfw. So the external, the C compiled dynamic library is essentially blowing up, and Rust cannot peer into that dynamic library to find out because it's an exception that's happening outside of the Rust binary, if that makes sense, and it's not able to capture all of that what's going on over there. So obviously Rust is calling into, if you go back, Rust is calling into libc start main. So that's the actual function, the foreign function that it's calling underneath, and that is what's blowing up, and then it's sort of coming back and being sort of caught in Rust land effectively. So that's a bit of a shame, and obviously, but at least in terms of actually compiling the damn thing, it does compile, and it is possible to compile. It's not a problem. It will be interesting to obviously dig into why. It may be some weird dependencies. For example, I think they mentioned about static in their dependencies. They did mention that you require some of these statics. So I think it's not this one, libfw. So it's not that one. If I go back, they mentioned something about having static, and you can use Podman. That's fine. Yeah, they did mention about using C static libraries, as the init binary is statically linked package glib static in Fedora. So, I mean, patch shelf, yeah, there was certain dependencies I was missing, and that was very trivial to install those missing ones. I think the other one was like BC as well. So these are like typical build tools that you have in the sort of C++ world. But it may well be that perhaps I was missing this. That's my only thing. That's what I believe it could well be. But that's only for the SEE variant. I was just going for the generic one. No, you need it. No, it looks like you need it for the generic one. So I suspect it may be because of this. It may be because I didn't use glib static essentially for the init binary that is statically linked. So I will have another stab at this to see if I can actually get it working. It would be wonderful, but it is progress in in the sense that now this multi-stage compilation does actually now work. So this works, as does this, as does this. The only issue is this particular one, as well as this libkrun, as well as krunVM, they both expect the shared library to be in the system-wide USR/lib64, as opposed to where it doesn't, where both of these actually install it, which is USR local, which is the local logged in user essentially, which is, I don't know, I'm not sure why, but I from the documentation I couldn't see them any mention about that, and I'm doing something wrong, and it might be just a sort of schoolboy error where in the configuration somewhere you have to set that up or tell it to. I mean, presumably you could use something like the environment variable, which is the ld underscore library underscore path, something like that, and then set that. Potentially that could be another way, but anyway, as I said, I tried ld-config, which is usually the way that you would, I guess, set and tell the linker which specifically path to look into. For whatever reason, that didn't seem to work, and the only way I could get it to work, and as I said, it's a dirty hack, I don't like it, it was to literally copy those libraries and then put them into the system-wide USR lib64, and that seems to work, and that seemed to compile. But anyway, until next time, I'll see you on the next one.